Hello everybody, let's continue our journey into neural networks. So as we can see here, we now have 4 layers of neural network. This is layer 1, this is layer 2, 3 and 4. So you can see these two are hidden layers, and the layer 1 and layer 4 input and output respectively. Now let's try to solve some problems using neural network. Let's start with some very easy problem. Then we'll go for some complex problem and see when our basic perceptron is not able to solve the stuff and neural network comes handy. Okay, let's see. Let's take a case of AND. Okay, we want to implement an AND logic using neural network. Okay, and we'll use one layer till the point it is possible. That means we'll use one layer perceptron and try to, which is very similar to linear regression, and try to solve AND problem. Okay, so what is AND problem? And we all understand what is it. Okay, to let's see the truth table of AND. Okay, so as you can see, this is the truth table. So you can see this is theta 1, this is x1, x2, and the values corresponding to it. Okay, and when on doing AND, this is the value. So this will be 0, this will be 1. We want to implement a single layer perceptron which can solve this problem. Okay, given a particular value of x and y, it can do the prediction for us. Let's see. Okay, it will really give us some understanding how the weights work and everything. Okay, so what neural network would do is it will typically find the coefficients, that is the weights of the connections, right? We have the input, we know the output. It will typically help us finding the value of coefficients. That is the end goal. If we can find the value of these coefficients, that means by having different value of feature, we'll be able to get the outcome. Okay, so let's see this case to understand this line better. We have x1, x2 as features. This is your bias, okay, and this is your output prediction. We want to find the value of this coefficient so that this model can work for us as AND predictor. Let's see. So hypothetically, we found out based on some initial parameters, and we found out this is the value of bias, this is the value of the coefficients. Minus 30 is your bias, plus 20 and plus 20 is your coefficients. Okay, now if we try to implement this, let's see how it works. Okay, so x1 0, right? Okay, 0 into plus 20 doesn't matter, 0. Then x2 0, so 0 into plus 20 0. Then of course the bias is irrespective of the feature values, the value is minus 30. So when 0 0 is the input, your neuron, this artificial neuron, generates an output of minus 30. Minus 30 is then passed to the activation function. The activation function we are using in this case is pretty simple, sigmoid function. Okay, what it does is anything which is less than 0, it rounds it up to 0. Anything which is greater than 0, it makes it to 1. Okay, so as you can see here, it is less than 0, so it is converting it into 0. Okay, similarly in this case, you have 0 and 1 as input, and if you put 0 and 1 here, 1 minus 1 into plus 1 into 20 is 20, and plus 30, so it is again negative, 0. So this is how the entire truth table was generated. So we can see that if we predict the weights as minus 30, plus 20 and plus 20, it can help us predicting, it can help us solving AND gate problem. Right, that is what we understand from here. So single layer perceptron is really capable of solving AND gate problem. Let's try to do the same thing for NOT gate. This is what we intend to do. So this is only one value, as you can see here, and if we predict the value of the weights as plus 10 and minus 20, it is able to solve the problem. Okay, so far so good. Our single layer perceptron is able to solve complex problem of NOT and. What about things like XNOR? Will it be able to solve it? As we can see that, as we have successfully done it in the past, single layer solved for AND, NOT, but it is not the same for XNOR. as we can see here. So for implementing XNOR using multiple layers, okay, we need something like this. Okay, we have this as one layer, this is another layer. You can see data from this input layer is going to both the units in the second layer, and the output of second layer is going to the third layer. So what it tells us is to implement things like XNOR. Okay, it is really a benchmark to understand. Okay, XNOR is definitely a thing which your neural network, which your single layer perceptron cannot solve, but definitely a neural layer network can solve this. Okay, if you try to implement this in graph, it would look something like this. Okay, so if you implement XNOR, you can see 0 0 0 0 is 1, 1 1 is 1. Okay, this is 0, this is 0. So it is very difficult to create a linear separator between this data. Okay, you cannot create a linear separator between this data. You need something like neural network to separate this data out. Okay, and that is where multiple layers come into picture. Now I think we understand why multiple layer neural network can solve complex problems. One last thing before you get deeper into it. Okay, how to do multi-class classification. So as you can see in this 4-layer neural network, we have input layer. So it definitely tells us the 3 features. These are 2 hidden layers and the output layer. So you can see here 4 node units in the output layer. It tells us that this is possibly we are trying to find out for 4 classes. Okay, if it is a 2-class output layer, then you can 1 node is sufficient. But if it is 4 class, so this is vector for 1 class, this is vector for another class, vector for the 3rd class, vector for the 4th class. Okay, so if you are trying to solve classification problem, the number of units in the output layer will be same as number of classes we want to classify. If you are trying to do solve regression problem, the number of units in the last layer will be only 1. Okay, thank you. Let's continue the rest of this stuff in the next video.